possibility to warm our oocytes and embryos in our lab. So we all know that for cell cryopreservation we must avoid intracellular ice crystal, and this is known since 1940. We can do this through vitrification, which is the conversion of a super viscous liquid into glassy state when cooled below its glass transition temperature. It's very important to point out that any material can vitrify, and this is directly dependent on viscosity of this material, the cooling rate we are using, and this is inversely dependent on the volume of the sample. To increase viscosity to our cell, we use cryoprotectant. Some cryoprotectant can permeate the cell. These are intracellular cryoprotectant. Some other, we use it just to create an osmotic gradient. These are large molecules, and these are extracellular cryoprotectants such as sucrose or trehalose. So, to obtain the vitrified state, we can use two protocols, the slow freezing protocol or the vitrification protocol. The kinetic vitrification protocol is increasingly used worldwide. Nowadays, more than 90% of the lab worldwide are using the kinetic vitrification with these small carriers, specifically the cyan carriers, very viscous medium, and they plunge the cell directly into liquid nitrogen. But we still have slow frozen oocytes, embryos, and also variant tissue in our cryobanks, and in some cases the company already withdrawn the thawing solution for this variant tissue. So, in vitrification, we need to obtain the intracellular glassy state. This is possible through vitrification by using very viscous medium with high concentration of cryoprotectant, and we plunge the cell directly to liquid nitrogen, as I said before. But this happens also during slow freezing throughout the cooling procedure due to the permeation of intracellular cryoprotectant as crystals form in the cryopreservation solution in the straw. So we can say that slow freezing is just an intracellular vitrification with ice in the extracellular compartment. So this makes slow frozen cell much more stable when we handle this cell. So 2 years ago we tried to use the vitrification warming protocol on slow frozen oocytes. The rationale of this study was that if we were able to demonstrate that it is possible to rapid warm slow frozen oocytes, this is potentially possible for any reproductive cell and any reproductive tissue, irrespective of the freezing protocol. To do this, we used ready-to-use warming kits with the first warming step with 1 molar of extracellular cryoprotectant, and second warming step 0.5 molar of extracellular cryoprotectant. This is what we observed. We performed a randomized study on seedling slow frozen oocytes that were donated for research, and we observed a significantly increase in survival rate when performing the rapid warming to these slow frozen oocytes. We also activated by parthenogenesis these oocytes, and we observed that the developmental competence of these oocytes was comparable. Then we also observed the meiotic spindle, and we did not observe any difference between the conventional thawing for the slow frozen cell and rapid warming protocol. What was interesting that we observed survival rates which were comparable with the actual vitrification, kinetic vitrification protocol. Then we tried to replicate this study as a multi-center study. We involved 3 centers, more than 400 oocytes donated for research, and which were slow frozen, and then we randomized for thawing with 2 different rapid thawing medium, which were thawing medium by SAGE, and oocyte thawing region, which was the originally medical. And then in the third group, we rapid warmed this oocyte. Surviving oocytes were divided into 3 groups to study by time lapse the parthenogenetic activation, and then we also observed the spindle presence and the configuration of the spindle. Again, very interesting, we observed that the survival rate was significantly increased in the group in which we used the rapid warming protocol. The survival rate was 90%. So rapid warming significantly increased survival rate, and we confirmed our previous observation. No differences we noticed on the parthenogenetic activation rate, nor in the speed of cleavage of these parthenoids. I think this was the first study on time lapse on parthenoids. Neither in percentage of 8-cell parthenoids. Again, the spindle, we did not observe any significant difference on spindle present, both when it was observed by polarized light or confocal microscopy. Neither we observe any difference in normal spindle configuration within the 3 groups. This is a normal spindle, this is our normal spindle. So this means that by removing very quickly the cryoprotectant also on slow frozen oocytes, we did not observe any negative effect. So, after this pilot study, we observed that it is possible to redefine the scenario between slow freezing and vitrification, confirming the pivotal role of warming, indicating that slow freezing results can be improved. But most of all, we tried to figure that this protocol can optimize costs in IVF lab. Imagine that in your fridge you can have just one warming solution, and you can use that warming solution for any oocyte, embryos, ovarian tissue, irrespective of the freezing protocol, irrespective if this oocyte comes from your lab or maybe you received from another center. So, how we can apply this in our daily routine? We know that oocytes and embryos are vitrified with various commercial kits. We know that oocytes are very sensitive, and we have demonstrated that it's possible to thaw by using the warming solution with 1 molar sucrose. For oocytes, this is potentially applicable also to embryos. This study is still unpublished. It has been accepted at ESHRE. So this is the first time that we present this data. The embryos, we say that can be vitrified and warmed with commercial kits. There are only slight differences in their composition. If you talk with some colleagues, they say, okay, I've used the Kitazato-media to thaw these embryos that were vitrified with SAGE, but it remains to be demonstrated that a warming solution of one brand can be used to thaw vitrified embryos, embryos vitrified with another brand. So we did this prospective, very strict randomized study from almost 100 ICSI patients. These were the criteria. So before vitrification, we used the software and we randomized the patient for vitrification kit by Kitazato and SAGE vitrification kit. So it's very important to point out that Kitazato contains 3 alloys as extracellular cryoprotectant and are supplemented with hydroxypropylcellulose, and SAGE contains sucrose as extracellular cryoprotectant and are supplemented with human serum albumin. Both involve sequential steps with 1 and 0.5 molar of extracellular cryoprotectant. To perform this study, we use the cryotop carrier. So, at warming, again we use software to randomize the embryos, and so the embryos were randomly warmed either with Kitazato or SAGE warming kit. Specifically, some embryos were vitrified with Kitazato and warmed with Kitazato. Some other resulted vitrified with Kitazato and warmed with SAGE. In group C, they were vitrified with SAGE and warmed with Kitazato, and the last group, they were vitrified and warmed with SAGE. And this is the first time we present this result. So the endpoints were survival rate and secondary implantation rate. Look, we did not observe any significant difference between the 4 groups. Survival rates was only over 95%. The same is for implantation rate. So survival and implantation rates were statistically comparable. This is the first time that we can present this kind of study. So in conclusion, we know that billions of embryos have been frozen by using different vitrification kits. Kitazato kits can be used in various combinations. So the universal protocol based on 1 and 0.5 molar of extracellular cryoprotectant, whatever cryoprotectant, can be sucrose or trialose, allows efficient thawing of vitrified embryos irrespective of brand, cryoprotectants, and basic medium contained in the freezing kit. So this is the first time that we can demonstrate this. This finding optimizes costs, simplifies lab routines, and facilitates embryo exchanges between IVF centers. So this is the take-home message for universal warming. What's universal warming? It's a procedure for reproductive cell tissue, irrespective of freezing protocol, type of cryoprotectant used at freezing. Optimizes thawing procedure for slow frozen cell tissue that we still have in our cryobanks, including ovarian tissue, so this is very relevant for cancer patients. And we have demonstrated that it is possible to thaw embryos vitrified with another brand vitrification solution. So this optimizes the thawing of oocytes and embryos transported from other centers. Thank you for your attention.